Hello everyone, in this video we are going to make the lightning effect with the shortest path nodes, and these nodes are newly added into the geometry nodes in Blender 3.3, and we are going to make the surface as well as volumetric lightning in this video. So let's get started. So first I'll briefly explain the working of these three nodes, and then we will make the lightning effect. So this shortest edge path node is similar to Google Map. Google Map give a shortest route from city A to city B, and this node give a shortest edge path on a mesh surface from a start vertex to the end vertex. Or we can also have multiple start or multiple end vertices. And if we want to convert that path, that edge path into a curves, we can convert that with the help of this edge path to curve node. And if we want to select those edges which are the part of the shortest path, then we can select with this node which is edge paths to selection. So for our lightning effect we only need these two nodes. So let's delete this and add the grid here. You can use any mesh surface. So in this tutorial I'm going to use this grid, which give a more nicer effect for the surface lightning, but you can use any mesh surface. Okay, so let's connect this. So we have this grid, and if I plug this node into this and then connect this next vertex index to this input of edge path to curve node, and we have nothing because we haven't specified our start vertex and also the end vertex. So let's do this. Let's add the index node, and then I'm going to add the compare node with equal operation. So let's plug that into the start. So we have specified our start vertices, and let's duplicate this, and I'm going to specify our end vertex. And this grid is 50 by 50, so the end vertex probably 50 into 50 minus 1. You can choose any end vertex. Okay, I am here using the last vertex of this grid, so you can use any vertex. So we have this path from start vertex, which is with the index 0 to this last vertex. So this node find this shortest path. Okay, and if we want to only select the edges of the grid which has this shortest path, we can select that with this edge path to selection node. So let me demonstrate that. If I add here a delete node, and let's plug this next vertex index into this node, and this selection start index start vertices selection to this node, and then plug this into the selection, we will have this. Okay, see, we are deleting those edges which are part of the edge, or we can reverse that with the not node. So we have this similar result, but this is a edge pass instead of a curve. Okay, this is how this selection node works. So but in our lightning effect we only need these two nodes. So we have this edge. Now another thing on Google Map we can do is that if we want from city A to B, it give a shortest route, and if we put a constraint like means find the route that have a less or minimum traffic, so then it may give a different route. So similar to that, in shortest edge path node we have that facility or that feature like this edge cost. So here we can use a different weight to define the edge cost, like vertex weight, vertex color, or noise. Or if you want to find the path through a hill, you can specify the slope of the hill or the height of the hill. Okay, so here I'm going to use the noise because we are doing this for the lightning. So let's plug this into the edge cost. Let's also make this detail and this roughness 0. Let's scale this 2. Now it find this path. Okay, so why this path? Let me show you how it is working. Let's add the store node here, store named attribute node, and plug this into the value, and I'm going to name this as W because this basically a weight, and let's combine them. Okay, and then add the set material node here, so that we can visualize our noise on the grid. So let's add the attribute node, specify the name of the attribute, and plug this or color into the emission. So we have this noise. Let's add the ramp node, color ramp node here, and let me hide this wireframe. So if I dial back this down around 0.5, so we can see that this node is finding the path from the region which has lesser value of this noise, so that the overall edge cost come out minimum for this path. Okay, if find this way means if I change the noise, it going to find the different path. So it will always find the path that has overall minimum edge cost. So this is how it is basically noise is affecting this path. So let's delete this because we don't need this for the lightning. Okay, to convert this path into a lightning or electricity spark, we have to do two main steps. One is before this edge path to curve node, and one is after that. Okay, so before this node, we going to offset this grid. Okay, let's add the set position node, and I'm going to offset the grid with the noise. So let's add the scale node, and then add the subtract node. So why I'm doing this is because this noise is from 0 to 1. Basically this noise field is 0 to 1, and I'm recentering that from minus 0.5 to plus 0.5, or basically I'm dealing with the direction of the noise instead of with the magnitude of the noise field. Okay, so let's make this scale 0.25 and detail 0, and this scale to maybe 3 and distortion 1. So we have this after this is before and this is after, and after the offset I'm going to triangulate our mesh, because our mesh is like was squares, and if you triangulate that triangulate the mesh or grid mesh, we get a more nice path. See, so we have on this kind of path from A to B vertex, or from start to end vertex. And if we change this edge cost, we are changing this path. Let's increase the scale maybe 5 and distortion to 2, so we have more variation, maybe around 10. Yeah, so let's add a multiply node here, and then connect this into a frame so that it automatically change with time. This looks like a lightning or a electricity spark, but we have to add more details, which is step after this edge path node. First let's smooth this with the fillet node, limit this, change this to 3 and this to 0.35, more round edges. After that we're going to offset on this curve. So let's duplicate this setup and we're going to offset this curve with the help of noise. Okay, so change the scale to a 0.025 and increase the noise scale around of 50. So see, we have, this is before, this is after, and we can also further increase this in fine detail by adding a subdivision of curve. Okay, so let's frame this. This is our this is offset and triangulate step, and this is our basically path, and this is smooth and fine details. Now it looks very nice. Let's add a more number of start vertices. Here here we are using only one start. Let's add more vertices. Let's add the random value node, change this to boolean, and I'm going to use very less probability value because we are dealing with the 50 by 50 grid. So let's do this. Now we have this, and if we change the seed, we have different branches. And let's also connect this to the time so that automatically seed will change with time, maybe 0.25. Now it looks like a lightning, maybe 0.002. Yeah, okay. So now let's add a bevel to this curve. So let's first capture the random because I want each curve have a different radius. Okay, so for that we have to capture a random value per spline. Okay, per spline, and then we need a set curve radius node, and then we also need a C2 mesh curve to mesh node. Okay, add here a circle, curve circle. This radius may be 0.5 and this value be 0.01, this to 1. Okay, so we have this, and if I plug this into this, we will get a different radius per curve, and we can taper these curves with the help of spline factor. Let's multiply this with this the random value, and if I plug this into this, we have this taper. These curves are taper to the start, and we can control this with the ramp node, the fall off on this taper, maybe 0.35. Okay, and we can also add another random value which will be a per point instead of per spline, so that will add a more randomization to the radius. So let's plug this into this, and this may be 0.15, and this also 0.15 because we shouldn't want the spline has a 0 radius. So this is a step. This step is for the bevel. Bevel, So we have almost completed the lightning steps for the surface lightning. Okay, this is the surface lightning because we are doing on a 2D grid. So let's add a material to this curve. Set material. So let's add material this one, and let's delete this. Add a mission. Let's call this mission material. Strength around 150. Maybe this thread. I'll add the bloom. So we have this. Maybe this purplish color. So we have this. I think this radius is slightly high, this scale, for fine detail. Maybe even less, 0.15. Now I think it looks nice. See, we have this lightning. So this is a surface lightning. It has some 3D structure, but it's mainly in the 2D plane. So another thing we can do is that if suppose we have object, we have some text. Let's type B for blender. So scale this down and also add some extrude to this B letter. Let's add 0.25. So we have this. Let's select the lightning. So if we want the lightning should avoid this letter, means doesn't go through this letter B, then mainly we have to add edge cost, means the edges which are close to this B mesh should have a large value of edge cost. Then automatically this lightning avoid this geometry or this mesh. So that you can also do with the help of proximity node, which is this. And let's bring this text here, plug this into this target. Let's add a map range node here, and we want the minimum distance should have a large value around 5, and higher distance has a 0 value of for the edge cost. Let's add this math node, and are we going to add this into our noise? Let me make some room here. So now let's decrease this around 0.025. It is not going through B, means if I move this B, see it is avoiding this B, means it is not going through this B letter. Because it is completely procedural, we can type anything, maybe KS. Let's stick with B. Okay, this is how you can avoid make the lightning avoid a certain mesh or object. Now let's make a 3D lightning or volumetric lightning. So for that we have to construct a 3D grid. So let's duplicate this. Let me hide this text. So we have this 2D grid. Let's make division 15 by 15, and then we're going to add the extrude node, and we're going to extrude by vertices. So we have these edges, and then add the integer node, and this will be the number of subdivisions along the this z axis, and we also need z size. So let's add the value node here, type around 1, and then we're going to divide this by the number of divisions in the z axis. That will give us offset scale. Okay, so we have this, and after that we're going to add the duplicate elements node to duplicate the edges. This number is 15 times. Now we have all these 15 sets, but all of them are on the same place. So to offset them in the z position, let's add the set position node, and then if I add the xyz combine node here, if I plug this into this, we have all these 15 sets, but we have to multiply with this index by this offset scale. Okay, we have this 3D grid. Because we have duplicate input grid here, we have 15 copies, so we have to merge them into a single mesh so that we have a 3D grid as a single mesh. So now we have this 3D grid, and let's add the switch node so that we can switch between our 2D and 3D grid. So let's switch that into 3D, and let's connect this. So now we have this lighting in 3D. Let me also disconnect this avoid geometry. So let's focus on this 3D grid. So now we are getting this 3D lightning. I want to specify that this last vertex based on a empty position. So I want to find the vertex which is near to this empty, so that will be easy to specify the end vertex or the start vertex. So let's bring this empty here, and first we're going to calculate the distance between this empty and the position of the grid points. So we have this distance, and after that we need this static attribute static node. Now let's plug this into this geometry and this as our attribute, and we're going to find the minimum and maximum of our distance or attribute. Then add the map range node, and this as our minimum and this as our maximum value, and this is the input. Now let's hide other outputs from this node. We have mapped this distance from 0 to 1. Now let's add the less than equal to node, and with the help of this value we can control how many vertices should selected by this empty. Okay, this will be our threshold value. Okay, let's make a group for this. Let's use this as our end vertex. See, we can now control the end vertex with this empty. Now we have this 3D lightning. So if you increase the number of divisions, we get a more and more details in this lightning. And here you can also use this as edge cost so that the lightning avoid that mesh. So we have this, see, it is avoided by this 3D lightning or volumetric lightning. Here you can also control the number of start vertices with an empty, and basically you can direct this lightning into a different region in 3D space, which is really handy. Means if you want to focus this lightning onto a certain object. So this is it, and if you want to download my project files and other preset, you can download from my Patreon page. If you like this work, then please do support me and subscribe to my channel for more updates. Until next time, happy noding, bye.